Hi. Well, I never thought I would have to repair another one of these, or restore, I should say, another one of these. It's a Sony TA-N86. I've done a video about this amplifier before. I own one myself, and a gentleman reached out to me after seeing my video. He's in Tennessee. I'm in Queensland, Australia. And he was interested in having me look at his TA-N86 amplifier as well. So he sent it all the way from Tennessee to Australia. It has arrived safely. And yeah, I've taken the fascia off, and I've taken the lid, the top cover, and taken the bottom cover off as well. You can see down there. So what I usually like to do when I'm working on something that I don't know the history of is just kind of look over it, get an idea for see if there's any obvious faults, any obvious issues, and it looks pretty clean. And the owner did point that out as well in correspondence. He said it looks pretty tidy inside, and I would say that's pretty true. So yeah, one big tell when you're looking at something that's been worked on in the past, so if we flip him upside down, is if you look for shiny solder joints, you can often see where people have been. So right there, someone has desoldered that diode. They may have suspected it was bad. I don't think it is. And then likewise there's another diode someone's replaced, actually, I believe. And there's various other shiny joints around where someone has desoldered and probably tested that component, or otherwise suspected it was bad. But I can almost guarantee that the problems with this amplifier are going to be in this thing, and that's the power supply. So it's a switch mode power supply, very early, designed by Sony in the 70s, and it runs very warm. So inside there it gets really hot, and over time, over the course of 40 odd years, over 40 years actually, the PCB inside can get baked, and I've seen two examples. The one I own had quite a burnt PCB inside, and then I got another TA-N86, a Japanese version, and surprisingly its PCB looked almost mint condition. But yeah, it's really a gamble what you're going to see when you open this up. I guess it depends on how often, how rough of a life it's had, and how much probably the amp has been run in Class A mode, because it is switchable between Class A and Class B on the rear of the unit. So if you're running it in Class A mode, this thing runs really hot. Like the heat sinks get hot. It's biased to like 300 millivolts or something crazy like that. So yeah, this is just kind of an intro video. I'll be going over all of the main board first, and then, well, I'll probably extract this first, but I'll just leave it to the side, and I'll go over all of the main board. Very likely I will be replacing all of the electrolytic capacitors, and the tantalum capacitors as well. There's a couple of tantalums there on the bottom. And yeah, there's a good chance that the electrolytics will be reading low, which is exactly what I saw with my unit. There's a whole bunch of I think there's 8 1000 microfarad capacitors. Those ones standing upright. Oh wait. Yeah, sorry. Yep, they are 1000 microfarad 50 volt. So you can't read them in circuit, even with with a little ESR meter. You have to extract them to get a good reading on those ones. And the main filter cap there. I'll probably replace that. I didn't do it in mine, but for this customer, I think I will do it, because that's what he wants. So it probably is okay, but I think it's worth doing. Yeah, so that's just a brief intro. Oops, squashing something there. I'll be replacing the mica insulators there. I think they're silicon. Sony use silicon insulators on them. And yeah, I just prefer mica and grease, even though probably I'd get scoffed at by a lot of people. It is messy, but it does perform well for the price, when the price is pretty much next to nothing. I've got some decent mica insulators from DigiKey, which I bought when I was restoring my TA-N86. So I've got some spares left over. I've got a lot of spares for this unit, including all of the, not spares, but brand new capacitors for those 1000 microfarad ones. I don't have that. I'll need to buy one of those. And all those small value caps, I will have good quality Nichicon or Panasonic or Rubicon replacements for those. So yeah, it looks pretty decent. I did notice as well there was a couple of transistors down there. I'm not sure if they're original. I'm kind of hoping that they are, and someone hasn't just swapped in some random replacements. They may be okay, but it's always concerning when you open something up and there's just a whole bunch of components swapped out. You start to get worried that it might be a basket case. But the good news is I don't think anyone's opened this, and I'm not surprised, because it's not easy to get to, and it's probably pretty intimidating for a lot of people to work on them. And it might explain why this customer has approached me and seen that I've done these amps. They're really not that hard. They do take a lot of time to get this out, because extracting the actual PCB from this is a bit of a bitch. You've kind of got to unscrew. There's like a whole bunch of screws holding it in, and then when you get the screws out, there's a very, like with mine, the heatsink on the PCB inside is coupled to this chassis itself, like the enclosure, and because of the dried out heatsink compound, it just gets stuck to the metal. So you really got to finesse it to get the PCB out of there. So that's the bulk of the effort required for these amps is that switching power supply, and also the transistors that they used in this power supply are a little bit difficult to get, but well, they're not really, but they're not exactly, you can't just go to DigiKey and get easy swap-ins. That was my experience. You've got to try and either find, I don't know, I can't remember exactly, but I recall that I ended up buying the originals, and that was more or less the recommendation from what I can remember. So yeah, I rambled on a bit, sorry about that, but yeah, that's an initial overview of it, and yeah, I'll be essentially going over the whole thing and replacing what I think is necessary and what the customer wants. He also wants the speaker terminals replaced, and I'll be doing that. And I'm not sure if he wants the incandescent bulb replaced. I replaced mine with LEDs, and it looks pretty decent. Like I very carefully chose LEDs that sort of replicate the original look without much flicker, or any flicker really, that I can tell. So I may do the same for him if he wants to do that. Anyway, I'll be back with another video, or I may just stitch another video onto this one. Cool. All right, quick update on the Sony TA-N86, the second one that I'm repairing. So I got the power supply board out of the case, the sardine can as it's called. This one looks really good. So I think it's had a pretty easy life so far. Normally, like what I see, if it's a heavily used unit, is that there's sort of discoloration there, like it's really black on the board around this area. But this one looks really good, really clean. I have taken all of the electrolytics out. I've just got these back in there so I know where they go when I get the replacements. And I'll be getting replacements, which I've ordered on DigiKey last night, so they'll be here in a week or so. They're the other capacitors out of that area there. So actually, surprisingly, well, maybe not so surprisingly, given the condition of the board, the electrolytic capacitors in here were pretty decent. Like, they tested okay on the ESR meter. Bit of corrosive glue there, that'll be removed. So yeah, I was a little bit surprised to see that all of those capacitors are okay. But you know, with that said, I will definitely be replacing them. What'll be going in here are Panasonic FC 105C rated capacitors, which are automotive grade ones, and I've used them when I refurbished my N86. Also, I've taken all of the transistors out, so for the switch mode, so they're all the switching transistors mounted on the bottom of the board. Taken each one of those out, measured the HFE values, reapplied thermal grease on the little aluminium pieces there, and those transistors are all good. And likewise, these three are okay. All the other little transistors have been tested and confirmed to be fine, so they'll be staying. So yeah, this board's pretty good, like I said, and I'll just be doing the caps on it. And then yeah, I'll clean up I've already sort of defluxed a little bit. I still need to clean it up a bit more once I put the final capacitors in, and then that will be done. Then I'll be moving on to the main board. There's a silicon piece that goes along there, which will have thermal compound reapplied to it. So yeah, these are the caps for the main board. 1000 microfarad upgrade to 100 volts, because they're actually the same size as the old ones, which are rated at 50 volts. So we're just going up in voltage, which is generally okay to do. And yeah, these are all Panasonic as well, I believe. I bought these a while ago for my refurbish. Yeah, that's the Matsushita logo there, that little M. 105C rated. Yeah, so these 8 will be going in to the main board. And yeah, likewise, these tested okay as well. I remember in mine, I had some of them that were down to between 500 and 600 microfarads, whereas the 8 capacitors in this amp that I'm working on now, they're all okay. So, but yeah, doesn't matter. They'll be replaced. You can't rely on a simple check to confirm these are good, and they tell you if a capacitor is bad, but they're not going to tell you how much life is left in an old capacitor. So yeah, all new ones will be going in. Just a list of caps that I'm getting. I've already ordered some micas as well, mica insulators for the output transistors. And yeah, that 1000, just one of those big filter caps for the that single one on the board, 160 volt rated. That's the big boy. It's funny because you have to because capacitors have gotten smaller and smaller over the years as the manufacturing capabilities improve, I suppose. It's often you have to go up in voltage. I think the one I got to replace the filter cap is rated at like 400 volts or something. And that's the same dimensions as this old cap from the 70s that was only rated at 160. So, and if you don't do that, then if you don't go up in voltage or try and pick a capacitor that's, you know, beefier to match the old dimensions, to match the dimensions of the old cap, you'll have issues with lead spacing and potentially diameter if there's brackets involved, which there are for the filter cap. So yeah, that's one way I try and keep everything nice and neat, and also going up in the voltage rating is beneficial as well, usually, I think. Anyway, that's a quick update on where I'm at with this one. It shouldn't take too long. It's really just waiting for the parts now. Cool, I'll be back. Okay, I've been going through the main board on the TA-N86. At the start of the video I mentioned that I like to go over the unit just to have a look and see if there's been any repairs or obvious damage and stuff like that. And I mentioned that there were some shiny solder joints, which would indicate someone's, you know, had a crack at either repairing it or trying to just test components at least. And yeah, so a couple of the transistors that did have shiny joints on them are these two, just down behind that resistor there. And I could sort of tell they were, even looking from the top, because they were pushed in a lot further than the factory transistors. So those two are actually replacements for, what are they, 2SC, I can't remember, I'll have to look up the original spec, but what they are at the moment is their MPS A06. I haven't looked that up yet, but I do know the pinout just using a little multi-tester. So the pinout from the left to the right is emitter base collector, and it looks like what they've done, whoever put these in has put them in, they put that one on the right there, that one's in correctly, the pins match the silk screen and the schematic, but that second one there is in wrong. So on the schematic, and those two transistors are part of the protection circuit, that's them right there, Q303 and 304, and the emitter should be tied, the emitter of Q303 should be tied to the base of Q304, and that's not the case. So yeah, this might explain the issue, and in fact I just realized before I started filming that I haven't even described what the issue is. As you know, as detailed by the owner, they mentioned that there's distortion on both channels was the original report, and then when I checked with him again before he sent the unit, he mentioned that it was playing up on, I think it was playing correctly out of the right channel, and then he reset the wires on the left channel, and then it was sounding bad as well. But yeah, that's definitely wrong, and what I'll obviously be fixing that and putting in suitable replacements. The originals were not sent over, they may be damaged, but yeah, I'm a bit sort of concerned about why they were replaced, but yeah, I'll be putting in some new ones and putting them in the correct orientation as well. What else? Yeah, so I took out the driver transistors on one of the channels, don't know which one it is. They actually test fine, so they're good, these two. What I've been doing, what I did for this one, I'll show you the difference. So I cleaned the carbon buildup on the legs, which is quite common to see. I've heard people say that carbon can go up into the transistor and cause it to fail or cause issues, I don't know, with noise or something. But I just got a fiberglass pen, gave that one a clean on the right there. That's the HFE measurement written on the back. But yeah, looking good. I'll do that for the other ones. But yeah, these will probably be okay. I'll be reusing those. Yeah, so yeah, well, just sort of point out that failure, or that issue with the incorrectly installed transistors. That definitely could be causing problems with distortion coming through the speaker if that protection relay is not working. But I'll be going over the whole amp, so yep. Anyway, that's a quick update. Cheers. All right, so quick update. Something else I found, this is still in the protection circuit. There is a 100 microfarad low voltage capacitor there. And I will have to review my earlier videos, but whoever was mucking around with this amplifier has put that capacitor in backwards. So that wouldn't have helped. But what I was starting to suspect is a problem based on the description that the owner's given me with the distortion on the output. What I've done is I noticed that whoever was messing with this had removed, sorry, not removed, they had desoldered the pins on the relay, and there's another relay there which I've removed. Presumably they thought there was something wrong with it, but I noticed that they didn't actually take the whole relay out. So they desoldered the pins, the main two pins for energizing the relay, but they didn't desolder these four. So I don't know what they were doing, but I thought, I'll have a look at the relays just because I'm servicing it. I'll clean the contacts and have a look at the relay inside, see that it looks okay, and it does. But what I've noticed is that if I manually actuate the relay, and I have my multimeter hooked up to the pins, like pin 1, 2, and then 1, 2, I'm not getting continuity. So I think there's such a buildup of carbon on these contacts that they are not, there's no continuity there when the relay is energized. So I'll show you. I've got my multimeter here. Where's the leads? So if we just hook, doing this one-handed, hook one lead to there, another lead there. So we're on those two pins, all right? What should happen when I manually actuate the relay and push it forward, when those contacts, when that leaf makes contact, we should be hearing the multimeter beep, but we're not. So that probably explains the no sound issue that the owner reported, and it possibly explains the sort of distortion. People say distortion, and that can mean choppy sound. I would say faulty relays, someone would describe that as distortion, and that wouldn't be crazy. So yeah, what I'm gonna do is get some very fine sandpaper and get it in between those contacts there, and then I'm gonna clean it up and put some deoxit on there. It's got some deoxit D100, and then I'll be back and we'll see if that's if there's continuity. Cool. Okay, I've cleaned the contacts. I've got the multimeter hooked up to the pins, and this is what should happen. So yeah, these relays, well, this one was so grubby that I'm guessing it would energize it, but then you would get no sound or very flaky sound, which is probably the root cause of the issue that this amp was having. Someone has tried to mess around with the protection circuit, thinking potentially that it was related to that. And as a result of that, they've installed components around the wrong way, probably made the issue worse. Luckily, it doesn't seem that there's any blown up stuff around that area, but yeah, what I'll do now is, now that that relay's working nicely, I'll take this one out and we'll have a look at that. But if it's, if it's dirty, I'll just clean the contacts and deox it, and that'll be it. And then now that the protection relay's, back how it should be, well, not yet, but it will be once I put the proper transistors in there. It should, I'm guessing it should just work. And then obviously the recap will help as well. And then, yeah, I think we'll be done. I've actually already done the small value caps there as well. So yeah, Panasonic FC, they're Panasonic as well. So these are in the protection. And we've got some Muse bipolar caps there, and that's on the audio path. Same over the other side. There's one tucked under there. That's a 1 microfarad. Oh, there it is. 1 microfarad, 160 volt. Waiting on DigiKey for that one. Got these, but don't want to install them yet because they're so big, and they it's easier to work on the board when there's not 8 giant capacitors on there. I'll probably replace these diodes here with beefy ones. Yeah, that one's done. And then the power supply will be done separately, waiting on caps for that. So cool, I'll be back. Okay, getting closer to the end now. So what have I done? So I've replaced the the original insulating material there, which was silicon for mica and grease on the output transistors. I've done all the capacitors, including the filter cap. What else? I've removed the speaker binding posts, and at the moment they're just taped off. And I've finished the power supply. So all new caps there. They're Panasonic FC, the automotive ones. These are Rubicon, I think. Oh no, sorry, they're Panasonic as well. Panasonic there. That's Panasonic there, and an Inchicon there for the 0.47 microfarad. All the power supply has been done. It's essentially just ready to put back in its die-cast aluminium case, and then back into the unit. The transistors that I was talking about in my last section were replaced. So I had a donor unit, which is a Japanese version, also a TA-N86 non-B variant. So that I took the transistors out of there for the protection circuit. Everything else is good. I've actually, earlier I had I've got my step down transformer there, transformer door for the American voltage, which is 110 to 120, I believe. It's 110 there. And I had the power supply hooked up in the test configuration, which is, yeah, a bit precarious, but it was fine. And adjusted that for the 90 volts as required for, as per the service manual. So yeah, everything's looking pretty good. I think the next step will be to fashion the speaker terminals for this. So what I plan to do is just a piece of aluminium flat bar and screw it in from the outside, just a bolt and nut there either side, and I'll mount the speaker terminals, just some standard looking ones, similar to, where are they, similar to this. This is just from an old speaker, but it'll be like the 5-way binding posts. So I'll get some decent ones from maybe J-Car. J-Car have some okay ones. And yeah, I'll install some new binding posts there. So the old ones are in this bag here. They're the old push down. They're not too bad on the Sony, to be honest. I've definitely seen worse. These ones are not too bad, but if you've got decent speaker cables, you know, the modern ones, not many people are using bare wire speaker speaker cables anymore. I am, but on my Sony. But yeah, there's the old filter cap. All the old components are in this bag. Oh, these are from the switch mode power supply. There's only 8 or so caps in there. But yeah, I think we're getting close, and I'll do the speaker, put that back in its shell, and then I'll adjust the bias. I'm not going to replace those potentiometers for adjusting the bias and DC offset, because usually these types are pretty good. Like, they don't really, they're sort of sealed in a way. There's no dust, can't really get into them because of the way they're designed. Whereas if they were the open air trimmers, I would definitely be replacing those. But I didn't replace these potentiometers in my unit either, because they were fine. Yeah, that's pretty much it. Thanks, guys. Okay, we're gonna power it on. Got it all hooked up. Got the grounding leads for the switch mode power supply. Got the multimeter hooked up to the test points, and we should be seeing 90 volts DC. The relays. Pretty good. So yeah, to adjust the voltage, it's that potentiometer just there, which I've already done. So if you leave it powered on for a couple of minutes, it eventually settles to 90. Sort of hovers around there. I think it might even be sort of self-regulating, because I noticed it would go below 90, it would go to like 89.98, and then it would sort of move back up to 90 once it got that low. So yeah, the power supply is good. After that recap, I mean, it was probably good before the recap, to be honest, but it's good for another 30 years now, at least. So I'll button that back up. And then, yeah, we're pretty much done. The board's done. I'm waiting for some speaker terminals on the rear. When I was checking those diodes, I did make a small mistake. Well, it's pretty easy to lift traces and ruin the solder eyelets on these old boards, so you got to be careful. So you can see a repair that I've done there. Just had to scrape back the solder mask on the trace, and then got a bit of just wire, single core wire, and soldered that on. Made a little loop for the diode leg to poke through. So yeah, that's a solid repair. I originally had a jumper wire connecting from the diode leg to the capacitor. So, you know, that one there, but I thought it wasn't good enough because the diode leg was sort of still, it could move around. So that'll be a more permanent fix. Yeah, so cool. Just a quick one. I will be back once I get the speaker terminals. I'll show you this is a piece of aluminium flat bar, which I'll cut. It's decently thick. Just focusing. Focus. So, yeah. cut 2 pieces off there, and they will go in behind and screw in from the rear. That'll be that. Thanks, guys. Okay, we're doing the what is it? DC bias. Yep, DC bias adjustment on Class B mode. So connected to those 2 points there for the left channel, those 2 points for the right channel, and we should be getting 20 millivolts on both sides. So at the moment it's been on for maybe 3 minutes, 4 minutes, so it's climbed up to 6.8, and over on the right channel 8.2. So what it says is adjust RT102 and 202 for 20 millivolts on the multimeter, and those RT101 and 2 are that one there and that one. So it's starting to climb, so I'm wondering if I should just give it, you know, another 5 minutes or so before I adjust it. But just to show you, where is it? It's this one here. If I adjust this, I'll turn it to the left. Yeah, you can see that's gone down to 5. So turn it to the right, and we're at 8.9. So I'm just gonna let it sit for a while, maybe another 10 minutes, just to sort of fully warmed up, and then I'll do that adjustment. The adjustment for the Class A is similar, just different hookup points for the multimeter. Same hookup points for the multimeter, a different adjustment potentiometers. So you need to adjust those inner ones for Class A mode. So the mode switch is on the back there. So in the middle is Class B. So yeah, I'll do that adjustment, and yeah, that should be that. Oh, there's other adjustments, obviously. There's the Class B amp adjustment. I can't really do that because I don't have a distortion meter, so I'm going to leave that one alone. And the other one is, I've already done that, so that's the I've done the DC voltage adjustment for the power supply, but I haven't done the DC balance adjustment because you need to hook speakers up to do that one. And at the moment there's no speaker terminals because of the because I'm replacing those for the owner. So cool, thanks guys. Okay, we're almost done with the Sony. Just a recap of what's been done. So on the power supply, full recap, Panasonic FC 105 rated for that. All the transistors and diodes tested, heatsink compound replaced on everything that had compound. The board was reflowed and the voltage was adjusted to the service manual specification. So just overall, the power supply was in pretty good shape, and it wasn't the issue as I initially suspected it would be. The power supplies, yeah, it was good. So the main board, full recap there, Panasonic FC as well where appropriate, Nichicon Muse for the audio path capacitors, and then some Kyocera tantalums on the bottom. The drivers, excuse me, the drivers and output transistors were tested and confirmed to be okay. All of the MV diodes were tested, which are those spider egg looking ones. They're all good. Protection relays were disassembled, cleaned and tested. So they were these ones here. They are pretty much the root cause of the issue that this amplifier was having. So they're all good to go. This one here was also disassembled and cleaned. It wasn't too bad actually, but cleaned it anyway. What else? The heatsink compound was replaced on all of the output transistors, which are the only ones that have compound. So they didn't have compound, they had silicon insulators, but now they have mica and grease insulation. The speaker terminals were replaced, and the wire connecting those to the board was also replaced, and the bridge rectifier, which I forgot to mention, was replaced as well. Some beefy 3 amp 600 volt diodes there, so the HER 306, which is those ones. Yeah, so the speaker, I think the most difficult aspect was the speaker terminals in the end, which is ironic because usually I don't have much trouble with those, but they're quite substantial, bigger than what I thought they were going to be. So it was just really difficult to get enough heat into the terminals for the solder to be able to flow onto them. I had to break out the beefy old Goot soldering line, which I don't use very often. Yeah, it's not the cleanest job, but it's definitely in there good, and it's not going to move. These terminals even have screw down hex nuts, which was handy because it held the wire in place for me. Fabricating the aluminium brackets was harder than I thought it was going to be, just because I'm not really a metalworking guy. So that was all done by hand, and it was just, I made a mistake on the first pass and just really messed them up because I was trying to use a stepper drill. But yeah, that was a big waste of time. But we got there in the end, and they're nice and straight. Got some just M3 bolts holding them in. Some Loctite holding the bolts on, but they're not going to move because that's all been that's all been tapped, those holes. So, and then I'll just show you what those terminals look like. Let's try and flip the unit around. So yeah, that's the terminals. They're quite nice. That's all metal. Obviously it's insulated from the chassis, but I thought they're apparently rhodium plated, but I don't know about that. Maybe it's true. But yeah, they're pretty good. They're nice and smooth. I put some deoxide on them so they run nice and smoothly. Yeah, that's pretty much it. Now I just have to put the fascia back on. I've tested it, ran it, connected to some speakers. It's all good, sounds great. Tested in Class A, tested in Class B. All works as I would expect it to. These are the old speaker terminals. So if you really were fussy, I'll send these back to the owner, and if they were to sell this amp in future and someone wanted to restore it back to default, you could do that. You'd have the little holes there, but I think this might even cover. Maybe not. But yeah, you'd have holes there, but I don't know why you would want to go back to bare wire terminals if you've got these, because these can accept bare wire as well, obviously. They've got nice big chunky holes there for heavy gauge wire if you want to use that, if it sounds better to you. And then yeah, this is the wire that was inside that was connected to these old terminals, quite thin, and then that's the wire that's replacing it. That's probably not going to focus for me, but yeah. So that is just there. So yep, as I said, it's all running nicely, and just need to put it back together now, and it's good to go. So I'll be back with one more clip showing the end result. All right, done with the Sony. The last thing I had to do was replace the LED. Replace the incandescent bulb with an LED, because the incandescents in these units are really dim, almost impossible to see unless you're in a dark room. So I'll do just a quick sound demo, nothing high fidelity. These are actually vaporwave tapes, so they've all been recorded by just people in there, they're not professionally dubbed or anything like that. So we've got the step down running. So nice and bright now, the LED. Okay, C88. Got tape in there. I won't force you to listen to all of this song, just hear the start of it. So yeah, works nicely, you get the idea. Quite a difference between the colours, isn't there, when they're side by side. I think I actually prefer the, you know, the US colour, the Japanese colour as well. I think it's just, the problem with the B variants is that over the time, the coloration, like they've got some sort of UV coating or something on them, and they sort of go a bit like yellowy, which wouldn't be too bad if they were all consistent and came from the same environment where they've aged exactly the same, but you build a stack out of components coming from a bunch of different places and you're going to get slightly different, you know, slightly inconsistent color, which is a bit annoying for someone like myself. It's a bit pedantic about that stuff. But yeah, all done. Nice amp, obviously. I like them because I have one. It'll be boxed up and sent back to the owner. Hopefully, you know, gives him many years of faithful service. Sure it will. People, these amps have a reputation for being like pipe bombs, I've heard them referred to as, but you know, they're still here, and aside from the power supply being a bit of a pain to open, I think they're pretty reliable. Anyway, thanks for watching, guys.